If you work in tech, or maybe you just follow how these huge software projects actually get built, it's rarely a perfect straight line, right? Welcome to the deep dive. Today, we're going to cut through some of the noise and try to understand one of the really key frameworks in the software development lifecycle. It's called the iterative model. So, our mission here, using the research and detailed sources we've gathered, is to give you a kind of shortcut, a way to really grasp this flexible, adaptive approach to building software. We want to know how it works exactly, and why certain big, complex projects seem to rely on it so much, and also what are the hidden costs, the trade-offs you really have to think about. I think most people imagine building software as like building a house. You need every single blueprint totally perfect before anyone even digs a hole. But the iterative model, it kind of flips that idea completely. It recognizes that, well, not all projects can start with a perfect, full list of requirements, or even should.
Right. And that inability to nail down every single requirement right at the start, that's actually where the model gets its power. It's built for, let's say, progressive discovery. So instead of waiting for everything to be perfect, you begin with something simple, a basic implementation, really.
Yeah.
Just a small working piece of the whole puzzle. And from that point, you go into these repeated cycles, predictable cycles. The system iteratively enhances these evolving versions. It keeps growing until the full system is built and it's ready to go live. So just to be clear, the core idea here is really two things working together. You've got development through repeated cycles, that's the iterative bit, and then you combine that with building it out in smaller functional pieces. That's the incremental bit. You really need both for it to work properly.
Okay. Let's unpack that mechanism a bit more then. If we're developing these small pieces, multiple times, how is that structurally sound? I mean, compared to models that demand massive architectural planning right at the beginning.
Well, the iterative and incremental approach, it forces you to combine iterative design thinking with an incremental build process. So you're deliberately dividing this potentially huge project into smaller, much more manageable builds or increments. And this is key. Each one of those builds, each iteration, it's basically like a mini SDLC phase in itself. Think about it, right? In just one iteration, that specific module, that piece you're working on, it still goes through its own requirements gathering, its own design, its own coding, and crucially, its own rigorous testing. And then the thing you produce at the end of that iteration, it's guaranteed to add a working functional piece on top of the previous version. So it's always growing and it's always functional.
Right. And the research we looked at really emphasized how continuous this feels. Because the cycles are relatively short and focused, you often find multiple iterations actually happening at the same time, don't you? Like one team might be coding iteration 3 while another is already designing iteration 4.
Precisely. Yeah, that happens a lot. This structure, sometimes people call it evolutionary acquisition because the product is constantly evolving towards its final goal, right? And the acquisition of new features or requirements, it happens incrementally over time, not all jammed into the initial contract or plan.
Okay, I want to zero in on quality control for a second. If you're constantly building on previous work, how do you stop, technical debt from piling up? What makes testing so critical here?
Yeah, testing completely changes its role. It's not something you just do at the end anymore. It becomes this continuous, ongoing requirement. Honestly, the success of this whole model really hinges on rigorously validating the requirements for each piece and then verifying and testing every single software version within its cycle. You basically can't or shouldn't move on to the next cycle until the current one is properly validated.
And it gets even trickier, right? Because as the software evolves, cycle after cycle, all those tests you wrote for the earlier parts, they have to be run again, repeated, and even extended to make sure the older, established bits still work perfectly with the new stuff you just added.
Exactly. It's regression testing, but kind of on steroids. You're not just guaranteeing the quality of the new feature. You're constantly ensuring the stability of the entire system as it grows larger and more complex.
Okay, so quality is baked into each cycle. Let's drill down into what one of those cycles actually looks like. Can you walk us through the standard phases you'd find in a typical iteration?
Sure. It's this cyclical workflow that really defines the whole thing. You usually start with the requirements gathering and analysis. But just for the small piece you're adding next, what functionality is needed now, then that flows into the design phase. This is where you map out the architecture for just that specific subset of features. After design comes coding. Pretty straightforward. The developers actually write the software based on that design. And finally, testing. Engineers make sure the code does what it's supposed to do, and importantly, that it integrates correctly with everything that's already been built.
So those four steps, requirements, design, coding, testing, that makes up one build cycle. But the real moment of truth, the thing that actually drives the whole system forward, it happens right after testing, doesn't it?
Ah, yes. That's the absolutely critical review phase. This is where the customer or maybe internal stakeholders, they get their hands on the working increment, the piece you just built. They check if it meets their current needs. And this is crucial. They give feedback. Do they want new features? Do they see things that need changing? And that feedback immediately fuels the next iteration. If they ask for changes, boom, the process snaps right back to requirements gathering for the next cycle, but now incorporating that fresh input.
You know, this constant feedback loop, it actually makes the whole process feel incredibly familiar to us just as regular consumers, even if we don't realize we're seeing iterative development in action. Like, think about apps you use every day, WhatsApp, maybe Instagram. They rarely do these massive, earth-shattering redesigns that change everything overnight. Instead, you see new features appearing gradually, things like message reactions or new video filters, maybe some minor UI tweaks. They get rolled out incrementally over time. You update the app and voila, there's something new. That is continuous development happening via iteration.
Exactly. And you can even visualize the improvement over time. Imagine a product being developed. One of the visual sources we reviewed showed this really well. It showed a system starting out in iteration 1. It had pretty low accuracy, maybe very basic color representation. It worked, but it's primitive. But then, by iteration 3, after a couple more focused design and development cycles, the same product now has highly improved accuracy, full color representation. And that wasn't some massive overhaul project. It was progressive development, focusing on delivering specific quality improvements and functional enhancements in defined, manageable steps.
Okay, so that incremental improvement keeps going cycle after cycle until eventually the customer's requirements are fully met. That signals the end of the main development phase, right? What happens next?
Yeah, once the core development wraps up because the requirements are satisfied, we shift gears into the final kind of post-development phases. First is deployment. That's getting the working system delivered and running in the customer's live environment. And then comes maintenance. This is the ongoing work, solving any bugs or issues that pop up in production, and of course, handling any new customer updates or feature requests that come up after the initial delivery.
Right, so the big headline advantage seems to be flexibility. But when is that flexibility really, truly necessary? What kinds of projects or maybe what conditions really benefit most from embracing this cycling process?
Well, the iterative model really shines in situations that are just full of uncertainty or complexity. It gives development teams a structured, controlled way to handle the unknowns. We tend to see it used most effectively under, say, 6 specific kinds of conditions. First, and this is probably the most obvious one, it's great for really large, bulky, or just inherently complex software projects, the kind that are simply too big to scope out perfectly on day one. It's almost impossible. Second, it's good for projects where, okay, the major requirements are mostly defined, but there's a clear expectation that certain features or enhancements will need to evolve over time, usually based on how users interact with the early versions.
That sounds like almost every modern software product I can think of. But what about speed? Does all this flexibility end up costing time?
Actually, it can often save time to market, at least in the short term.
Mm.
That brings us to the third scenario. When there's a really strict time-to-market constraint, you can use iteration to deliver a minimum viable product, an MVP, really quickly. Get something out there, and then you iterate to add more features and complexity later rather than waiting months or years until the entire perfect system is ready.
Huh. That's a really interesting trade-off, getting something out fast versus getting everything out later. What about when you're dealing with brand new technology, where the rules aren't even fully written yet?
That's our fourth scenario. It's ideal if you're using new technology that the development team is actually still learning while they're working on the project. You absolutely need iteration there to account for those learning curves, unexpected technical hurdles, things you just couldn't foresee. Fifth, it's perfect for projects that have some high-risk features or goals, things that, maybe due to market pressures or potential user feedback, might very well need to change direction down the line. You mitigate that risk by tackling it, isolating it, in an early iteration. And finally, the sixth one, it can be really helpful from a practical standpoint. Like when you know certain skilled resources, maybe specialists, are only available on a contract basis for specific defined periods. Iteration lets project managers plan for those resource needs in shorter, focused bursts.
That point about handling risk, like you mentioned, that really seems like the biggest strategic win for a project manager, doesn't it? It sounds like it turns what could be a single, potentially catastrophic project failure into a series of smaller, more manageable, high priority milestones.
It absolutely does. It makes risk management significantly easier because the really high-risk stuff, you typically tackle that first in the earliest iterations when the cost of something going wrong is generally lowest. Risks get identified and hopefully resolved during that specific iteration. It makes each cycle feel like an easily managed milestone. You're getting operational product delivery with every single increment. And any issues you find in one increment, you can use that knowledge immediately and apply it to the design and planning of the very next one. It's a built-in learning process.
Okay, now we have to flip the coin. Every model, no matter how great, comes with trade-offs. If we're focusing on efficiency and quality, what are the big advantages we gain by choosing this iterative approach?
All right, let's start with the upsides. First off, you get working, demonstrable functionality developed quickly and really early in the project lifecycle. And that makes it much easier to get early customer evaluation and feedback, which honestly is just priceless for steering the project correctly. Also, because you're breaking the work down into smaller chunks, testing and debugging become inherently easier. You're dealing with a smaller scope within each iteration.
And that focus must impact the bottom line too, right? In terms of cost.
It absolutely does. It's generally significantly less costly to change the scope or the requirements compared to traditional models, like waterfall, where everything's supposed to be fixed up front. Here, you're almost expecting change, so the process is built to handle it more gracefully. Plus, progress is very clearly measurable at the end of each iteration. And because of the modular nature, you can often plan for parallel development streams, which can help speed up the overall timeline.
Okay, so that's the flexibility advantage clearly laid out. But the trade-off we hinted at earlier, you're essentially trading that requirement certainty for, well, guaranteed high-level management overhead, aren't you? What are the key drawbacks, the downsides we need to be really aware of?
Yeah, that's the flip side. The first major drawback is that this model definitely brings complexity. It's generally not a great fit for smaller, simpler projects. Trying to break down a small system into even smaller increments often just creates more administrative work than it actually saves. It can feel counterproductive.
And that complexity, it doesn't just fall on the developers, does it? The whole organization, the management structure, has to be ready to handle this constant state of flux.
That's right. The research clearly suggests that you generally need more resources and critically, significantly more management attention.
Hmm.
Think about it. You're constantly cycling through requirements, gathering, reviews, planning the next iteration. That continuous involvement definitely burns through management time and focus.
And that increased need for management oversight probably trickles down to the skill sets required too.
It does. You really need highly skilled people, especially for that crucial risk analysis phase early on. Deciding what features go into which iteration, balancing risk and value, that takes experience. If you get that prioritization wrong, the whole evolutionary process can start to break down or head in the wrong direction.
Hmm.
Another potentially significant issue is architectural debt, because you don't gather all the requirements right at the very beginning of the entire life cycle. Sometimes architectural or system design problems can emerge later on, things you didn't anticipate, and fixing those might require extensive refactoring, basically recoding large parts, which would be costly and time-consuming. You might always feel like you're playing catch-up with the ultimate design vision.
And maybe the scariest downside, at least for the stakeholders holding the purse strings, is that the final project completion date, the deadline. It's often not confirmed. It tends to be more of an estimate that can and often does change with each iteration, especially if requirements keep shifting. That's a pretty significant risk when you're trying to plan budgets and resources.
Exactly. And that fluidity applies directly to the finances, too. The total budget is often not really decided or fixed at the very start, precisely because the scope isn't fully fixed. It makes financial planning a constantly moving target, which can be uncomfortable for many organizations.
So if we try to connect all this to the bigger picture, where does this iterative approach really fit into modern software development? Especially now, with frameworks like Agile being so common.
Well, the iterative approach is really foundational. When you look at these well-known, highly successful methodologies like Agile, and that includes specific frameworks like Scrum or Kanban, they are fundamentally built on top of the iterative model's core principles. Agile methodologies essentially adopted and then formalized these core concepts. The short development cycles, the continuous collaboration with customers, the rapid feedback loops, and the constant delivery of working software in these adaptive iterations. You could say the iterative model provided the basic engine, And Agile then added the specific processes, roles, and philosophies to really drive it effectively in modern teams.
Ah, okay. That clarifies the relationship perfectly. So, the main takeaway for you, our listener, the learner, is this. The iterative model is really defined by its progressive development style, its inherent flexibility, and its adaptive nature. It's pretty much the go-to approach when you expect requirements to be somewhat fluid, or when stakeholders really need to see and interact with the functional product relatively early in the development cycle, rather than waiting until the very end. We've talked about how iteration works as a series of these mini SDLCs, the absolutely vital role of that feedback and review phase after each cycle, the specific scenarios where this flexibility is most valuable, and of course that key trade-off, you gain that crucial flexibility, but it comes at the cost of increased management complexity and less certainty around the final schedule and budget.
Right. And since we know the iterative model is so heavily dependent on getting that initial risk analysis right, and it relies so much on continuous management attention and constant iteration throughout its entire run, it does raise a really important, maybe even tricky question for any team or organization considering it. When is all that increased communication overhead, that extra management complexity? When is it actually not worth the benefit of flexibility? And maybe even harder, how do product teams truly know when to stop iterating? When do you officially call a product done, especially in a world where software often feels like it's never truly finished?
That is a deep thought to end on, particularly, as you said, in today's world where software seems to be in a perpetual state of update. So we encourage you to think about how often you actually see the influence of this iterative development model in the products, the apps, the websites you use every single day as features constantly shift, improve, and evolve all around you. Until next time, keep digging deeper.